In this video, we'll show how to add persistent state saving to a system. Specifically, we'll make it so our skill tree system remembers which skills have been learned and how many research points are remaining between game sessions. In other words, it will remember our progress after we restart the game. So an elegant approach to add a save subsystem to a system is to have two events in the system's main component, save state and load save state. Then we can simply call these events at various points in our code when it makes sense to. The way local persistent saving works in Unreal Engine is to create a save game object and then save that to the hard drive. So in our components folder, we'll open up the skill tree component, and just in the event graph, we'll create those two events. So we'll call the first one save state and the second one load save state. And so in the save state, we're going to create a save game object. So we see we can enter a save game class here. We're going to create our own. So we'll go back to the content folder, misc data, and we're going to create a save game blueprint and a struct to go inside it. So we'll right click here, blueprint class, all classes, type in save game, and we'll call it BP STP save game for Skill Tree Pro save game. Then we'll right click in the graph, go to blueprints, down to structure, and this will be called s_skilltree save info. Let's do the structure first. We're going to add three variables. The first one will be the skill tree component class. And this is in case we have multiple skill trees in our game, we'll know which one to get. The second one's going to be learned nodes. So these are the skills that we've learned. And the last one's going to be research points. The skill tree component class is going to be an actor component, class reference. And just as a general concept, instructs whenever we make something a more base component, it just keeps the system lighter in general. And because we don't need it to be more specific than this, we can get away with this. The next one's going to be a name array, and the last one's going to be an integer. And now we'll open up our new save game object, and we're going to add the struct that we just created as a variable. So we'll call it skill tree save info, and it's going to be that skill tree save info. And that's all we need to do in both of these, so we can compile and close them. So now that we've created this object, back in our components event graph, we can add it here. And if we expand the list, we'll see what we just created. We'll drag off the return value here, and we'll set skill tree save info. Right click, split. So to find the class, it's going to be the class of this blueprint. So we can just get a reference to self, get class. And we already have variables in here for learned skills and research points. And they're both under skill tree start. So we can just drag them into here and connect them. So now we've created a save game object and set it to what we want. Now we just need to save it out to the hard drive. So we'll drag off this return in the create save game object. And we're going to async save game to slot. It's worth noting that we could also just save game to slot non-asynchronously. We're going to use async because this is essentially a faster operation. This one's a blocking operation, so the game code won't continue until this is finished. This one, the async does have a risk of, if it's saving when the game crashes, then it would not go through that save. But essentially the effect that would have is rewinding maybe the last thing the player did, like, they would have to retrain the skill when they log in. And it's an incredibly small fringe case, so the performance benefits, in my opinion, are worth it here. So we'll use the async. And something I just noticed is if you drag this off and type in async save game to slot as we did, it has this world context object reference that it automatically plugs into. What we want to do is we want to right click and async save game to slot, and then we don't have this world context. So we want to use this method here. Now we can save the name to whatever we want, and because we might have multiple skill trees in the same project down the road, we're going to differentiate this skill tree within the name, and that way when we're retrieving it, we'll know which one to get. And the way we can do that is we can copy and paste these two, self get class, and we can get class display name, and we can drag off this string here and run an append. And A can be Skill Tree Pro, and B can be piped into here. And what this is doing is making it so this specific skill tree has a specific name, so it will know which one to get in the future if we have multiples. And we can comment this whole thing, save state locally, and now we'll do the load save state. So here we can run an async load game from slot, and we can copy this functionality, pasting it down here and plugging it in here. So we're loading the same thing that we saved out. So what we'll do is we'll drag off save game cast to BP STP save game. It automatically connects to the wrong pin. We have to connect it to completed. And here we'll get the variable we created, get skill tree save info, and split that. And for now, we're not going to do anything with the class, but we could in the future. But for now, we do need to set our learned skills and research points from these. And we can comment this whole thing. So now we have the saving and loading functionality for our system, and the only thing we need to do now is decide where to call it in the blueprint code. For what we currently have, we only need to call these one time each, but in the upcoming videos, we'll add more calls. So when do we want to save the state? We want to save the state after we learn a skill. Basically, every time we learn a skill, the research points and learned skills will change. So it makes sense to put it there. So in the interfaces, STP/PC internal, we can go down to learn skill, and we can just put that in here. Now we want to make sure that this is updated after everything else happens. We could put it at the end here, but if we do it that way, then in the future, if we add more to the end, we would have to remember to move this back to the end. So to sort of idiot-proof things for the future, we'll put it right here after the branch. So if the skill can be learned, we'll do a sequence, and we'll call that new event save state. And this way it'll always happen at the end, no matter what, regardless of when we add more over here. We'll go back to the event graph. Now, when do we want to load the save state? We want to load the save state when this system first starts up, if we are deciding to use this persistent state saving system. So if we scroll up to the top here, it actually makes sense to put it at the end of begin play. I want to make a bool so that the designer can choose whether or not to use this system for this particular skill tree. So we'll add a new variable and we'll call it save between game sessions ? And we'll drag this to the tree behavior category and maybe put it up here under can examine unlearnable nodes. And we'll compile and we'll set it to the default yes. And so here at the end of begin play in our component, if this is true, then we will simply call that event that we created load save state. Now, one thing I like to do when I have a branch here in a long line of execution, because we may add more to the end later, you never know, is I just like to, for safety, drag a reroute off and connect the false to the reroute. And then that way, if I come back and work here, it's another way of kind of future idiot-proofing something. And we can comment this. Now, if we fire up the game and open up the skill tree and train a skill, now we see it's 9 research points and it's learned this skill. We close down the whole game and we open up the game again and open it. We see that it's learned this skill, but the research points is now back to 10. So it does remember that it's learned skills, but it doesn't seem to be updating. However, when we train it, now it's down to 8. So it was the correct number, it just wasn't showing it. The reason this is happening, if we go to our widgets folder and open up our skill tree base widget, when we're creating the skill tree, at no point are we checking the number of research points. We haven't put any functionality to do that yet. So what we could do is we can put it in the set starting appearance function here. At the end, we'll drag in the research points and we'll set text and we'll get the skill tree component, get the research points, and just set it here. Now if we fire up our system, open up the skill tree, we'll see that these 2 have been trained and there are 8 research points left. And so now we see that it remembers everything and the persistent state saving is in the game. It's also worth pointing out that the child component that we're using now has that bool in the tree behavior category, save between game sessions, and if we just turn it off, we see it's back to its default every time we open the game. But if we turn it back on, it remembers exactly where we were. And just to quickly show what this system is doing, if you navigate to your project folder and then go into the saved folder and then go into save games, you can see our save file is right here. Well, it's worth noting that this system works for single player games, for local games. But if you want something saved in multiplayer, this functionality would essentially need to be called on a dedicated server, and the dedicated server would then run this functionality along with the player ID. You can also see that if we just delete this file and then fire up our game, we'll see that it goes back to its default. Now, we currently have no way to unlearn skills or reset the skill tree other than going into the folder and deleting the file. So in the next video, we'll implement the functionality to unlearn skills and reset the skill tree.